Hello everyone. So today let's solve the problem climbing stairs, right? So problem number 70, climbing stairs. So what the question states here, we are climbing the staircase, right? So we are having certain staircases. We are climbing the staircase here. It takes n steps to reach the top. It takes some of the steps, right, to reach the top. Basically, n steps to reach the top. Each time we can either climb one or two steps, right? So let me show this one to you. Suppose, yeah, if we are having this one stairs like this, right? So suppose this is 0, 1, 2, 3. We can either go one step or we can either go two steps, right? So that's what they have said in the question. In how many distinct ways we can climb at the top? So suppose we have to climb from here to here. This is the top basically, right? So in how many distinct ways we can climb to the top? So that's what they have asked in the question. So either we can go see here one step and then by one step, right? So it will take four steps. It will take four steps to reach the top. Yeah, or we can just go two steps at once and two steps at second time as well. It will only take two steps, right? Two steps or four steps basically, right? Either we can this one. Each time we can either climb one or two steps. They have strictly mentioned here, one or two, not less than one, not more than two, right? So this is fine, I believe. Just give me a second here. Let me delete this one. Now let's go with the input, this one example that they have given one, right? So n we have been given 2 here. So there are two ways, right? N we have been given 2. So either we can take one step plus one step, or we can just take two steps at a time, right? So this one we can do just to reach the 2. So output that we get here is 2. So example 2 we have been given 3, right? So either we can go with this one. What do we call? So there are two ways, right? So here 1 plus 1 or 2, right? So we can just directly go with two steps. So there are two ways, two distinct ways. We need to return this one distinct ways, right, of climbing the top. So this one is fine. N equals 3, output we have 3. N equals 3, output we have 3, right? So this is fine. Yeah. So here 1, 2, 3. So this one is 1, this one is 2, and this one is 3 basically. This one is 1, this one is 2, this one is 3. So this is fine. So we can just go with 1 plus 1 plus 1, or we can just go with one step and then two steps, or we can just go with two steps and one step, right? So there are three ways to this one, three distinct ways to climb the top, right? So three we have to return here in this case. There are three distinct ways, so three we have to return here, right? So I hope this is fine, man. They have given us wonderful examples just for the sake of understanding. Now, as we are familiar with the question and the input output or the examples part, let's do one thing. Let's quickly discuss the approach. So we will be making use of the dynamic programming to solve this particular problem, right? So dp of yi will be the number of ways to reach step I, right? So base case will be dp of 0. Initially we are at the first step. dp of 0, this one base case, dp of 0 initially will be at the first step, right? So one way to stay at the ground. Also this one dp of 1 will be 1 as well. There is only one way to stay at the ground, and this one also dp of 1 equals 1 as well. So for I greater than or equal to 2, I greater than or equal to 2, dp of I will be dp of I minus dp plus dp of I minus 2. Like that. So last move was one step or the two steps, right? So we can just go with dp of I equals dp of I minus 1 plus dp of I minus 2. Simple. So when we consider this example, let's consider the same example for the approach. So dp of 0, we have 1. dp of 1 also we have 1 here, right? So dp of 2, dp of I is nothing but here we are considering n equals 2. This one will be dp of I minus 1 plus I minus 2. Here in this case, dp of 1 plus dp of 0. That will be 1 plus 1 basically. This will lead to the output 2, right? So the output that we got here is 2, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. DP approach works absolutely correct for this particular problem, right? So we can just make use of DP without any hesitation here. Now, as we are completely familiar with the approach, let's discuss the complexities. What will be the time complexity here? The time complexity would lead to big of n, because we will be computing the dp of I for every I from 2 to n. I greater than or equal to 2 we considered, right? From 2 to n basically. So overall time complexity would lead to big of n. So what will be the space complexity here? The space complexity would lead to big of n as well, because we'll be making use of the dp array of size n plus 1, right? N plus 1 for the safer side, right? So we'll be making use of the dp array of size n plus. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So first one, if n is less than or equal to 1, right? So we have to return 1 in that case, right? So let's write the same here. If n less than or equal to 1, let's return 1. This is fine, man. Now a dp of I will store the number of ways, right? So this one we know. Let's initialize the dp first, then we can speak about it. So I'll just go with dp equals new int of n plus 1. We have discussed this one already, right? Within the space complexity. Now there is one way to be at the step 0 and there is one way to reach the step 1 as well. We know this one. dp of 0 equals 1 and dp of 1 equals 1. Right, now let's move on with the for loop. Let's fill the dp from 2 to n and then let's recur, right? So recurrence is nothing but it comes from I minus 1 plus I minus 2. I minus 1, nothing but one step. I minus 2 is nothing but two steps. We can either climb one step at a time or two steps at a time. So they have strictly mentioned in the question here, right? So let me write the for loop very quickly here. Just give me a second. Yeah, iteration part. So this one has to be int I equals to I. So this one less than or equal to n I plus plus. So this one will be dp of I equals dp of I minus 1 plus dp of I minus 2. Very simple, right? So finally we need to return dp of n basically. This is nothing but the number of ways to reach the uh, reach step n, right? Number of ways to reach step n, basically reach the top, right? Number of ways to reach the top, basically. This is fine, man. Now let me format the code and hit the run button. I hope this works. Yeah, compiler. Oh yeah, we have to return here, right? So I didn't make use of the return keyword at all. Yep. Let me the run button. Yeah, the sample test cases are getting passed. So let me hit the submit button as well, man. Yep, this works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.